Afternoon, guys. I'm Brian Welch. I'm going to be talking to you today about techniques for upgrading Python format exploits. I'm a cyber operations officer over at Fort Gordon, and I just enjoy doing this research in my free time, so hoping to share some knowledge with you guys today. So we're going to start out pretty basics, just talk about format strings, some basic vulnerabilities you might encounter, and then we'll go into some of the exploit upgrade techniques, and then we'll finish it out with a tool demo for automating some of this stuff. So we are going to look at some code today, so if that's not your thing, I'm going to do my best to start from the ground up and just explain all the details. And we are only focused on CPython, so none of the other implementations. If you don't know what those are, then we're probably going to be talking about the Python that you do know and love already. And then all the code samples from this talk are only tested in Python 3.7, so if you run it on your own computer, try to mirror that environment. So we'll just start out with some background. So first, you see we got a little demo of what a format string actually is. It's just a nice way of formatting strings, really. It's a pretty descriptive name. You can just pass different methods or different values into it, and it'll turn them into a string for you how you want them. It's actually one of 3 different ways to do it in Python. You got your percent style strings, the dot format method that we're going to be only exploring today, and then newer versions of Python have something called an f string, which you see at the bottom there. But again, we're only going to be looking at the dot format method and the vulnerabilities associated with that today. So just right off the bat, we'll just start looking at how these things might be vulnerable. You see up at the top, we've got 2 pretty similar code samples, but there is a subtle difference, and if you notice, that's in these parentheses here. And what that's doing, it's causing our input that we're passing in to actually have dot format called on it as well. So when you're using format strings in your code, you never ever want to call dot format on unvalidated user input. And you see in the right sample here, that's actually what we're doing. So in this sample, that's just supposed to print your first name and then the first letter of your last name. If we mess around with it, we can actually access some Python attributes that we're doing here. And for those of you not familiar with format strings, this 0 here just means we're doing this to the 0th or first thing that we pass to the format method, which is this last name variable we have here. So now we got a basic understanding of some of these vulnerabilities. What can we do with this? So you can really kind of abuse the way Python stores different attributes on its instances of classes. So in this example up here, you see we have some sensitive data that we really shouldn't be able to access from untrusted user input. But because of the way we have this class defined with an init method on it, we're actually able to inject into the class attribute of the 0th thing we pass the format, move up to the init method, and then dump the entire global namespace. And this works just due to the way that Python creates its classes and methods on those classes. So when the CPython interpreter creates this class, whenever it executes this define statement or this definition statement to make this method, it's capturing the entire global namespace that that method has exposed to it at the time that that code gets executed. And that's all being packaged up in this globals dictionary. And you see from this format string injection here, we're actually able to dump out that secret token that you really shouldn't be able to read. So this is a pretty contrived example, but if you can imagine this super secret variable being something like an AWS key or other sensitive key you store in memory in your web application, then format strings are a way to read that data, which is pretty dangerous. However, we are limited in what we can do with format strings. You see in the below example here, we have another pretty contrived example of a calculator. And in our format string, we're trying to call the add11 method so we can print out 2. But in the error message we get, we see that it says calculator doesn't have an attribute add. And that's because CPython's not going to just execute any function that you call in a dot format string. It will do that in an f string, which is a newer thing about Python, but it'll try to only access attributes when you call dot format. So we can read the global namespace. That's pretty good in a lot of cases, but if we want to write like a real exploit, like execute arbitrary code or something like that, we got to dig a little bit deeper. So we're going to dig a little bit into the CPython internals. That's the code snippet we have up at the right side there. This is kind of how field resolution is done in a format string, you can see it's willing to do two things for us. That's call getAttr on an object and call getItem on an object. And we're going to explore that a little more in the next slide, but just know that we are able to trigger some kind of execution within a format string, and we're not only able to just access attributes or print strings or numbers or stuff like that. And the way this works is because of these three magic methods in Python. And that's the getItem method, the getAttribute method, and the getAttr method. And for those of you guys not super familiar with Python, these are kind of supposed to be interfaces for programmers to be able to create like list-like interfaces or other magic things where you can say my object dot a field and be able to pull that field up out of anywhere, no matter what. So if you're implementing like your own list type, you might use getItem, and that would let you access random attributes through the square brackets. So we kind of see an example of that in this format string down here, where we're trying to access the 0 index of the object we pass as the 0th argument, which is our getItem instance. And then we try to access some other attributes on 1 and 2 that we're also passing in our format call. And so getAttr and getAttribute are pretty similar. There are some subtleties in the differences in the way they operate, though. GetAttr will only be called if Python can't resolve the attribute you're trying to access through its standard methods, but getAttribute will be called no matter what. So if you're trying to implement your own magic lookup object or something like that, you probably want to go with getAttr because you can run into some weird recursive problems with getAttribute. But this is just trying to demonstrate to you guys that we can, in fact, execute some functions. Like we saw in the previous slide, we couldn't execute our calculator's add method, but we can trigger execution with getItem, getAttr, and getAttribute. So going on this theme, we're going to try to look for some gadgets within the Python standard library that have kind of vulnerable definitions of this getItem, getAttr, and getAttribute, because we can, in fact, execute code with them. So we have a pretty contrived example of something that would be vulnerable and would be usable by us. That's this file lister class. And we see a getItem definition that is just calling os.system. Os.system will just run a shell command for you, and this class is kind of naively just a pending pattern to ls to try to list something that matches that pattern. So you see we have an example here. We instantiate our object, and then we're accessing a pattern through the getItem square brackets, and it's printing out two different files that match that pattern. But if we use some shell operators, like we got the double pipe here, and that just means it'll execute the following command if the first one failed. We're actually executing in this line ls123 and then pipe who am I. So ls123 is going to fail because there's no 123 file, and then piping that to who am I means who am I is going to win. And it just prints out my computer name and username that you can see at the bottom when that dialog disappears. And right there. Yeah, I named my computer Brian Jr. All right, so now that we kind of have an idea of how we can abuse these different getItem, getAttr, and getAttribute methods, I did some digging through the Python or CPython standard library for different modules and classes that can potentially be abused if you can find them in memory in your format string injections. The first one I found of the two we're going to look at today is the file input module. And this is a module that just lets you read simultaneously from different open input streams. And that can really be abused because they did, in fact, provide us with a getItem definition that lets you read from different lines in the file. You do have to read these lines in succession, so it's a little limited. But if you had a format string injection and were able to find a file input object that's open, floating around in memory, you would be able to read data from whatever file is open by iterating through the square brackets that in turn call the getItem method of that class. So that is fairly limited. It doesn't give us code execution, but file disclosure is still a bigger win than just the Python reading from the Python global namespace. The next module I want to explore is called the shelve module. For those of you guys not familiar with pickling, it's Python's method of serializing Python objects into bytes that could then be stored on a file on your system or stored in a database. And this is a pretty cool feature, but it also has a lot of associated security vulnerabilities. When you're serializing and then subsequently deserializing bytes into a Python object, you're actually able to execute arbitrary code based on the input, or based on the bytes that you pass to the deserialize method. And so we can see that this get item implementation of shelf is doing kind of a lot. You're really only supposed to be reading objects from get item and not executing a lot of code on the side. It's kind of called a side effect. So you can see here that it's doing some lookups on the dictionary stored internally to shelf, and then it's calling unpickler on it, or instantiating an unpickler class and then loading it. So this isn't like a straightaway win gadget. You do need to do some massaging to get the right bytes in memory that you could then trigger through a format string injection. But what I want to do with this file input and shelf example is show you guys that when these get item, get attr, and get attribute implementations try to do too much, you can abuse them, and if you're able to get them in the right condition, you could use them for your own exploits to upgrade beyond global namespace reads. But when you're looking for these gadgets within a proprietary application, you don't necessarily have a lot of insight into what kind of code the application you're injecting into is running. So I've devised a way where you can actually extract the full source code of any applications that you're targeting. And the reason that this is possible is because of the code attribute that gets stored on function objects in Python. And this is a pretty cool side effect of the Python runtime, that whenever the Python interpreter compiles a function object, it'll store a lot of runtime metadata on that object, and that all is stored on this double underscore code attribute. So in the example we have here, we're just defining a simple function that's just printing something out. We're storing the code attribute, or we're printing it out rather. On this line, you see it's a code object. And this code object has a lot of different metadata on it. The first one that we're looking at being the co-code attribute. And you see it just prints out a bunch of random bytes. But that's actually the raw Python bytecode that the interpreter would execute when you actually call this function. And Python ships with a bytecode disassembler in the dis module. So over here, we're just printing out the disassembled bytecode here. So this gives a little more insight. It's not super readable if you're not familiar with Python bytecode, but Python's a stack-based interpreter, so it's just pushing some items on the stack, popping them off, and then calling our print function. And another piece of metadata on this code object is the co-const item, which you see here. Our string that we're printing is actually stored as one of these constant values. So these are just two of 10 to 15 attributes that are on these code objects. And if you extract all of them, you're able to reassemble these code types, and then we can decompile them back into source code. So there's some pretty cool Python bytecode decompilation engines out there. I think the best one is the open source Uncompile6 project, which does some pretty slick stuff under the hood to look for tendencies in Python bytecode, and it's able to reassemble them back into Python source code. So if we're able to actually pull out all of the double underscore code object attributes, we can package them back up into a code type, which you see here, and then these are all the different metadata attributes that we have to pull out. We only looked at 2 of them, but no, there's quite a few. And then we can decompile that code object with this function call here, and it prints out some of its decompilation metadata, and then you see it returns to us that print statement at the end, which is actually the print statement that was in our function we defined earlier. So that's pretty cool, and because all of these code attributes are just that, attributes, we can access all of them from format string injections. And because of this, we can kind of put it all together into a neat little tool that can automate all of this. And so kind of the steps we would follow are first, we have to manually find our format string injection vulnerability. This tool won't do anything magic for us in that regard. You do have to identify it yourself. And from there, if we're able to break into the Python global namespace, then we can actually read, then we can escape into pretty much any Python object that's loaded into memory, and that can also be adjacent modules into the one that we break into. And we can recursively visit everything in memory at that point and dump all of their different code attributes and decompile all of that, maintaining some kind of semantic understanding of where we're at in the Python namespace, and reconstruct vulnerable application source code. So in order to put all that together, I created this tool called Formatic. It's on my GitHub if you guys want to check it out, but I also have a demo prepared that we'll look into here. So we're gonna just look through some terminal output together during the tools runtime. If you guys aren't familiar with askinema.org, it's a pretty sweet service for recording terminal sessions. And this isn't actually video, this is all text you can copy paste. So I think if you guys ever do demos like this, I think it's a pretty sweet tool to use. But we'll dive into this right now. So we start out looking in the vulnerable application that we're going to use, for example, which is just a vulnerable command line application. So we'll start out looking there. You see there's some data, and we'll scroll down to the actually vulnerable piece of code that allows us to inject into it. So keep scrolling. So the actual reason we're able to inject into this piece of software is because of it takes the inject argument straight from the user, and then we'll call format on it. And as we touched on earlier in this talk, that's something you should never, ever do. So this application is vulnerable, and once we get through this examination, you'll see in the demo that we do inject into it just as a sanity check. But wait for us to exit from here. And then this is how the vulnerable command line application gets invoked. We can pass a format string into the inject parameter, and it will print out for us this dummy class. That is what is the parameter that gets passed to format. So next up, we're going to see this tool get run. So we invoke it as a Python module, and then what you pass to this tool is the actual command line of how you inject into this command. So you'll see we're calling the same thing, but we're calling the same command that we called just up here, but we're just having its fuzz parameter be these two @signs, and it'll inject all of the different format strings it's going to run into there. So we'll let it go. And you see right away it's already enumerating a bunch of different attributes based on the injection. So the first thing it's going to do on a class attribute, you actually have this bases tuple, which is all of the base classes of that class. Because this class only has the base class of object, you only see that it's going through the first one and trying to pull out different metadata from that class. But it's already able to pull out the doc string as well as the name and everything. But because that class is an empty definition, you don't see any methods getting pasted. But as we keep going, it's able to extract fully all of the functions that are within that class, including class level attributes up here, and it it dumps the full source code out to the terminal. So if we let this run, it'll keep recursively walking the entire global namespace. All of the different Python standard library modules are blacklisted, so it won't recursively walk forever. And then you see its runtime caps out, and we get to the end, and the last thing it printed out was the main method. So I think it's pretty cool that just from one injection, you're able to do all of these, able to access all of this different stuff and extract a lot of different sensitive information. And if you're able to find the right gadgets from the source code you dump out, you can upgrade your exploits to code execution or file disclosure. So as I've been reiterating during the talk, don't call format on untrusted user input. It's just going to lead to bad things for you. And then also, don't get too creative with your get item, get attribute, and get attr methods. They really shouldn't have side effects of any kind. And thanks for your time, guys. That pretty much concludes my talk. But you can find these slides at the link, and feel free to reach out, and I'll be taking questions now.
So you mentioned you're board here?
Yes.
Do you probably have your own server range, right?
Yes. Oh yeah, I like doing that kind of stuff for sure. CTFs and crack me's and stuff, yeah.
Have you used any of this findings here?
For different vulnerable machines, and yeah, not in my job, but in my free time. All right, well, thanks for your time, guys. Feel free to come up and ask me any questions if you have them. I do have some stuff to give out. I'll give the first one out to the gentleman that asked the question, but if anyone else asks a question, I'll give out something else as well. All blue. Sweet. All right, thanks, guys. Appreciate it. What?
This might be kind of dumb, but this was only on the dot format, or does this work with f-strings as well?
So f-strings isn't really vulnerable to this because they get evaluated at compile time, not at runtime. So it's not really applicable. But the color question did go first. So got